Welcome back! In the previous video, we expressed the law of demand. The claim that other things equal, the quantity demanded of a good falls when the price of the good rises, or equivalently, the quantity demanded rises when the price falls. In this video, we'll take things further with an example. Jim Carrey loves going to the movies. In the table below, you can see how many movie tickets he buys each month at different prices per ticket. This table is called the demand schedule. It's a table that shows the relationship between the price of a good and the quantity demanded, holding constant every other factor that influences how much of the good consumers want to buy. And in this case, we are dealing with just one consumer, Jim. Let's go through the entries within the demand schedule. If movie tickets are free, Jim goes to the movies 8 times in any given month. At $1 per ticket, Jim buys 6 tickets per month. At $2, he buys 4. $3, 2 tickets, and at a price of $4, he doesn't buy any tickets at all. Notice that as the price increases, Jim buys fewer and fewer tickets. This behavior is consistent with the negative relationship between price and quantity demanded stipulated by the law of demand. Let's now graphically illustrate the data within this demand schedule. Notice that on our graph over here, we've got price on the y or vertical axis and quantity demanded on the horizontal or x-axis. Now going back to our demand schedule and starting from the top and moving downwards, at a price of 0, in other words for free, Jim's quantity of tickets demanded is 8. This gives us this point on our graph. At a price of $1, 6 tickets are demanded. This is the corresponding point. At a price of $2, 4 tickets are demanded. $3, 2 tickets, and $4, 0 tickets. If we were to draw the curve that connects these points, we would get this straight line. And this is what we call the demand curve. A curve showing the relationship between the price of a good and the quantity demanded. Notice that we got a downward sloping demand curve, which is indicative of the negative relationship between price and quantity demanded. In other words, a rise in price results in a fall in quantity demanded, and vice versa. In the previous video, we distinguished between demand and quantity demanded. We said that quantity demanded refers to the amount of a good that buyers are willing and able to purchase, and that demand doesn't simply refer to quantity demanded, but to the entire relationship between price and quantity demanded. Both the demand schedule and demand curve capture demand. They reflect the entire relationship between price and quantity demanded. Between the two, the demand curve is a better way of capturing demand because it's a continuous curve and therefore allows us to see what happens to quantity demanded at any price level, rather than just the 5 different price levels presented in the demand schedule. For example, we could find what the quantity demanded would be at a price of $150. To do that, we simply move from $150 on the y-axis until we hit the demand curve, and we then move down for the corresponding point on the x-axis, which will give us the quantity demanded at that particular price point. This information is not reflected on the demand schedule. I'll close this video with a couple of notes. In general, in math, but also in other sciences, we plot what you might know as the independent variable on the x-axis and the dependent variable on the y-axis. If we were to classify our variables over here as dependent and independent, since quantity demanded depends on price, it is obviously the dependent one, and price the independent. Therefore, one might normally expect for the two to be plotted the other way around than the course of action we followed here. That is, one would normally expect price on the x-axis and quantity demanded on the y-axis. The reason we didn't do that is simply because in economics, by convention, the price is on the vertical axis and quantity demanded on the horizontal axis. Continuing with my final note, I previously said that the demand curve is a better way of capturing demand because it's a continuous curve and therefore allows us to see what happens to quantity demanded at any price level. With our demand curve in this example though, it's as if we assume that our good is perfectly divisible. For instance, it's as if we say that there's a price level where a gym would consume half a movie ticket, something which we do not observe in the real world. But this is just a quote-unquote technical issue that doesn't affect the conclusions we derive so far. And as we will see when we take the analysis from individual demand to market demand, this wouldn't really matter. Take care.